All right. Number, 24. 24 was on, I believe, second to the last test, maybe the last test. F of x is equal to x to the negative 1/3, and they want to know what is the derivative of the inverse. Now, what do you have to do first since they didn't give us any numbers? You're going to have to do the inverse. So this is y is equal to 1 over the cube root of x, correct? So what is how do you get the inverse? X equals 1 over the cube root of y. So now, can I write x equals y to the negative 1/3? Now, how do we do this derivative implicitly? 1 dx over is equal to negative 1/3 y to the negative 4/3 d. Okay, before I go any further, this is 1 is equal to negative 1 over 3 times the cube root of y to the 4th. So now, how do you get dy over dx by itself? Reciprocal will be a whole lot easier. So we get 3 cube root of y to the 4th, and that would be negative. Does that make sense? Is that one of their options? Yes. It was D, but I didn't do it right. Oh, wait a minute.
Is this not the one where you did the chart?
But we can't do the chart because we don't have x and y's. Oh, wait a minute. Here it is. Here it is. That's got y in it, doesn't it? Well, what is y? What is y? So we got negative 3 times the cube root of 1 over, I don't think that's helping at all. Okay. So this is negative 3. Do you agree that this is x to the negative 4/3? Yes? Yes? And then that's times 1/3? Oh, I'm not going there. There.
Ask Lyra how she did it.
Yeah, Lyra, how'd you do it?
She looked it up online.
What did I do wrong?
The x, all the way up to the point where it's x 1 over where the
Mm-hmm.
cube root of y, that's right. But then when I just found the derivative, it was like just 3 steps extra.
What's the answer choices, Brian?
Okay, what if we solved for y? Let's solve for y. We get cube root of y is equal to, cube root of yx is equal to 1, or cube root of y is equal to 1 over x. Yes?
Yeah.
Okay, so now I'm going to cube both sides. So I'm going to have y equals 1 over x cubed. So now I have y equals x to the negative 3.
Yeah.
So now when I do the derivative, it's negative 3x to the negative 2. So rule of thumb is solve for y, don't do implicit.
Negative 3x to negative subtract 1.
But that still doesn't give me x to the negative 2.
Lyra, solution? Yeah, wasn't it E?
Oh, was it b? Oh, I did get it then. I'm still thinking we should have gotten it that way too. So I must have done something wrong there. So anyway, all right. Questions on the homework? Homework questions? Yes, Megan. Oh, even answers. Good call. Okay. So for those of you who didn't bother to do their homework, no names mentioned, I will leave the recorder on in the event you want to go back and check your answers. Okay. So, number 2 is 256 pi over 15, which is the same thing as 53.617. Number 4 is 18 pi, which is the same thing as 56.549. Number 6 is 448 square root of 2 over 15 pi, which is approximately 132.69. And number 8 is 128 pi over 3, which is approximately 134.041. Number 10 is 153 pi over 5, which is approximately 96.133. Okay, now what questions do you have? Yes, ma'am. 6. You know, somehow I thought that might be a question, and I believe the problem with 6 is you all assume. So let's look at what you all assume. I know what assuming does because I had a student tell me what assuming does. All right, what was the question, Mackenzie? This is number 6. What was the question? 2 minus x. Y equals 2 and y equals 4 minus x squared over 4? Okay. There we go. Okay. Now, you all looked at the graph and made assumptions, didn't you? You assumed that the points of intersection were 3. But look what happens. I'm going to put 2 in for y, and I get 2 equals 4 minus x squared over 4. I'm going to multiply everything by 4. So I get 8 equals 16 minus x squared. Now, why would I want to do that?
Because you consider the fraction.
Right. So now I'm going to say 0 is equal to 8 minus x squared. Or x squared equals 8, and x is not plus or minus 3. It's plus or minus 2 square roots of 2. They tricked you. You looked at the graph and you made assumptions. This is why we set these equal to each other. So I'm assuming, who was top? Was 2 above? This one was above? So you're going to integrate from negative 2 square root of 2 to positive 2 square root of 2 of top, which you all just told me was 4 minus x squared, yes? Minus the bottom. Oh, wait a minute, we're doing volume. We're doing volume. Hold on. Aren't we doing volume? Okay. So it's, hold on. I've got to graph it, or I'm going to do this so wrong. All right, so.
You already did it wrong.
Oh my goodness. All right, now I don't need that one at all. Okay, I need a blank sheet of paper. And you're going to sit up in the front corner. So, negative 2 square root of 2 is almost here. Positive 2 square root of 2 is almost there, correct? So, we know we have y equals 2, correct? And this is y equals 2. What happens if I put 0 here? What will happen? You have 0 what? 0, 4? So that means I go over 0, I go up 4, yes? Okay, so what happens when I put in 1? What's 4 minus a quarter? It's going to be 3/4, and what do I have to do? Don't I have to square root it? Well, right, to solve? Oh, don't I have x? No. So I have 4 minus 3/4. So that means I go over how many? 1 up and 3 1/4, I think. I was working with both. This one. When I put 2 in, 2 squared is 4. I'm going to have 4. I'll have 4, 3, right? What happens when you put in 2 square root of 2? What's square root of 8 squared? 8. What's 8 divided by 2? 4. 4 minus 2? 2. So this is symmetric, so we're going to have something that looks like this, I guess. Well, you get the idea. Okay.
Pretty close.
Well, we're going to pretend.
Is it supposed to be a circle though? Because it's definitely a line.
So y equals 2.
Yeah, I know. But the picture that you drew, the little dots.
Oh, but they're really not. Okay. So from here, we are going, oh, what are we spinning around, by the way? What's the axis of symmetry? Axis of revolution. The x-axis? So is this a disk or a washer? It is a washer. So we go from the axis to the outside, axis to the inside. Ryan.
What's that first equation up in the top left corner?
I don't think that's part of the problem.
So what's my large R? Top? 4 minus x squared minus the bottom. No? Oh, yeah, it is. So this is going to be 4 minus x squared. So that's large R. What's my little r? What's the top? Minus the bottom? 4 minus 6. What? Oh, I just don't want it there. What can I say? So this is going to be 4 minus x squared over 4 quantity squared times your pi, right? And from that, I'm subtracting my other radius squared dx. So this is going to be pi times the integral negative 2 square root of 2, 2 square root of 2, and we're going to have, oh, we had to FOIL that, didn't we? So that's going to be 16. And then when you multiply these together, the 4's cancel. So it's going to be minus 2x squared. And then when we square that, we're going to have positive x to the 4th over 16, yes? And then we've got minus 4 dx. And what's 16 minus 4? And positive 2 square root of 2. So we're going to end up with 12 minus 2x squared. And from there, you have to finish it. I'm going to write that as 1/16 x to the 4th because I think it's easier to do. Okay. Other questions? Yes. Which one? 5. What did 5 say? Okay, so if I set x squared equal to x to the 5th, I'm going to get 0 equals x to the 5th minus x squared. So I'm going to factor out x squared, and I have x cubed minus 1. Does that look right? So x equals 0, and x equals what? 1. So that is going to be my points of intersection. Oh, wow. Well, anyway. So I'm going to put 0 in. Do you agree it's going to be 0, 0? This is going to be 1. And this is going to be 1. When I put 1 in, do you agree it's going to be 1? Okay, so if you try to graph this, good luck. So if I put in 1/2, what is this going to be? What's 1/2 squared? So I go over 1/2, I go up 1/4. So there is that equation. And now if I put 1/4 in, what is that going to be?
I don't know. Is it 136?
Is it a little sliver like this?
Oh, those are annoying.
Those are very annoying because I can't see them.
Like a banana peel with no banana.
It is.
You're a banana peel with no banana.
Okay, so we're going to integrate from 0 to 1. Who's on top? Hold on. I'm getting ahead of myself. What's the axis of symmetry? X-axis? Axis to top, to outside, axis to inside. So what's my large radius? It is a washer. It's a washer because it doesn't touch until that point of intersection. What's my large R? My large R is from the axis to the outside. X squared minus what? Or, what's my small r? X to the 5th minus 0, or? Okay, so this is going to be large r squared, minus small r squared. And I think that's going to give you pi integral 0 to 1 of x to the 4th minus x to the 10th. Okay, I'm going to condescend, and I'm going to show you a little secret. And I will not be the most popular person in the room when I'm done. You're going to be so unbelievably mad at me. It was very necessary. You know I had your best interest at heart, because I did not show this to you sooner. Uh-oh. I can't get my... Oh my gosh, I can't get it to work. Just leave it on my desk. File, new. All right, if you have a graphing calculator, if I were you, I would get it out. Well, it could or it couldn't be. But I am going to show you this because the worksheet I wrote, you will need to do this. You will need your calculator for my worksheet. All right, you ready? Ready? We are going to grab the calculator. We're going to turn it on. We're going to go to y equals. Okay, I believe pi is above the caret key. Am I right? So we're going to do second pi. And then I'm going to do parenthesis. I'm going to type in x raised to the 4th. Minus. Boy, we are rusty. X raised to the 10th. Right, so what did I type in? Pi x to the 4th minus x to the 10th, correct? So then we're going to hit graph. Now, I really don't like that. Okay? So I think what I'm going to do is I need to see this part right here. I don't like to zoom. I want to be in, no, listen, no. You want to be in control of your window at all times. You don't want to leave it up to the calculator. What are we integrating from? 0 to what? 1. So I'm going to make my x's 0 to 1. I'm going to make my y's perhaps -2. Darn. -2 to... Oh. There we go. -2 to 2. And I'm going to hit graph. Maybe. Can we see it better? Okay. So now what we're going to do is we're going to do second. Everybody hit their second button. Trace. Trace is next to graph key. Do you see number 7? Oh, we're going to choose number 7. And what does it ask us for? What is the lower limit? 0. And then we hit enter. What does it ask us for now? Upper limit, and we're going to type in 1, and we're going to hit enter. And what is it? Oh my, oh my, oh my. Yeah. So this is equal to 0.342. Am I right? So, what I'm saying now is I would prefer that you practice this. So I'm asking you to use your calculator for tonight's homework. Okay. Now, we are going to go.
I got an error.
Then,
When I did the upper limit, and I did 1, I got an error.
well, I'd have to see your calculator. So we are going to go to the notes, and we're going to go to that section where I started writing problems. So first year I taught this, my kids needed more work. And so what I did is I thought I'd be really smart, and instead of having to give them graph a lot, I would only give them 5 problems that they had to graph. And then all I would do is change the axis of revolution. Doesn't that make sense? Okay, so we already did this one yesterday. So, but what we didn't do is we didn't do this axis of revolution. All right? So let's go back. It seems to me yesterday when we graphed this, we had y equals 0, we had x equal 1, and we had x equal 4, correct? These are notes. Okay, so that calculator part was caught. So this is 2, 4. Remember how I did this? 6, 8, 10, 12, 14. So if I'm using this function, if I put 1 in, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared was 16. Do you remember that?
Yeah, the 1's up 2.
Darn it. Okay, so this is the fallacy of using counting by 2s. All right. So, yeah, but my graph wouldn't fit 1s.
Make a big graph.
All right, now, that's about as good as it gets, I want you to know. And that was a whole lot better than yesterday. So, the shaded region, and that's, some people missed questions on this next test because they shaded the wrong thing. Okay, and you shade the wrong thing, you miss them all. All right, so here we go. Are you with me? All right, so I am going to move all of this, and I am going to group this. Group. And then I am going to copy it because we're going to be using this over and over and over again. All right, and in fact, I might take my little camera, and I'm going to use my little camera, and I am going to take, I'm going to use my camera, and I'm going to take a picture just of this.
You can't do that.
Okay, so there's my, so now I'm going to take this, and I'm going to copy it, and I'm going to come back here, and I'm going to delete this, and I am going to edit, view, edit. All right. The reason why I'm going to do this is because I can make it bigger. Okay. So now what are we revolving around this time? Okay. And by the way, this is 1, 2, 3, 4. All right. So this is going to be my axis of revolution right here, correct? So now, are my rectangles going to be vertical or horizontal?
Horizontal.
They're going to be horizontal. So let's come back. And my suggestion, oh wow, let me bring this to the front.
So you're going to do right.
Order, bring to front. All right. So what my suggestion is that this is x equal 4, correct? This line right here is x equals 1. What is this? Y equals x squared, and this is y equals 0. Now, when we are horizontal, okay, can I use y equals x squared? No. So this is good because it's x equals. This is good because it's x equals. What do I have to do with this?
Make it so x equals square.
X is equal to what? positive or negative square root of y. What are the y's up here, positive or negative? So the equation I'm going to use for the moment is x equals square root of y. It's the same graph, but it is going to be, we're going to use the green. Now my question, and listen carefully, and this is where I went crazy not thinking, is this a disc only? Is this a washer only?
Both.
Or is it both?
At the bottom it's both.
Is there any shading
Bottom is the
that is touching the axis of rotation at more than one point?
yeah.
I think so.
Oh, I think so right there.
What is it told you?
That is a disc. So it is both. So what we're going to have to do is, now this is what I do. You've got 3 problems on my worksheet, I think, tonight. I'm going to say from x equal, actually, I'm going to say from y equals 0 to what? 0 to 1. And then I'm going to say y equal 1 to what? How high did that go? 16. So what we have is we have a disk. So how many radii should I have on a disk? 1. From the axis to the end. So when we're sideways, what do? We say right, which is, what's the right? 4 minus the left. What is the left? Is 3. Okay. So this is going to be pi times the integral from 0 to 1 of my radius squared dy. Correct? Plus, now let's talk about 1 to 16. Okay. 1 to 16, what do we have now? A washer. Axis to outside, and you should be saying this to yourself all the time. Axis to inside. So now there should be 2 radii. How do we do the big one? Right? 4 minus left, 1, which is 3. Little r, right? No, is not 1. What's the right? Square root of y minus what? What's the left? 1. So now this is going to be pi times the integral from 1 to 16 of large radius, 3 squared, minus small radius squared, dy. So now, how do you do dy's on your calculator? When you do your calculator, instead of saying y, I want you to say square root of the variable. And your variable key is that x key. So now, well, you'll have to get used to it. So I just want you to know that you would do this on your calculator. And then what you're going to do is you're going to stow this in alpha A. Didn't we store before? And then you're going to do this, and you're going to stow that in alpha B. And then what are you going to do? Alpha A plus what? Alpha B. And it'll give you your exact thing without rounding errors. Okay, so I'm going to go to another one. So what we have is we have the same picture. Notice I did not change it, but what did I change? The axis of revolution. Now I did this, again, I did this to cut down on your graphing. So now it's the y-axis. So when I go to do the y-axis, is it a disc only, washer only, or both? Okay. Is the shaded region touching the axis of revolution the entire? Oh.
It's the y, so it's a washer.
Okay, so I have done this wrong. Okay, y-axis. Y-axis. Okay, is it a disc only, washer only, or both? Okay, is it 1 washer or is it 2? It is 2 washers. Why is it 2 washers? It's a 2 washers because here, look at the representative rectangles. I go from the outside, right? No, from the axis to the outside, and then I'm going to do from the axis to the inside. With me? Here I'll do axis to outside. Did that change? Axis to inside. What changed? You see, the inside function here is different than the inside function there. So what we're going to do is we're going to say from y equal 0 to 1, we have a large R and we have a small r. Then we're going to say from y equal 1 to 16, we will have a large R and a small r. So let's start in blue. What's the large rectangle? What's the rightmost? 4. What's the left one? 0. So what is that large radius? Okay, small radius. What's the right one? 1. What's the left one? 0. All right, on green, what's the right one? What is the left one? 0. Because this is x equals 0. All right, so what is your large radius? 4. Your little radius. Now what's the right one? Square root of y minus 0. So when I go to do this, I will be integrating, and this is why I do this, because it gives me my limits, because otherwise I have to go back and rethink that. 0 to 1, what's the large radius? Large radius squared minus small radius squared, dy, plus. Now we're going to do pi, and we're going to, what's my limits? 1 to 16, all right, what's the large radius? 4 squared, what's the small radius? Square root of y what? Squared, dy. It's all about top minus bottom, right minus left, recognizing discs and washers. Do you see why I wanted you to do last night's homework first? Don't even think you're going to pack up. No, I don't think you're good. I think we need more.
We're bad.
You're bad about packing up. When I'm not done, I got more time. And I will use it. All right, y equals -1. Where's that? Y equals -1. Is that horizontal or vertical? It is horizontal. So the question is, am I going to have a disc only or washer only? Or both? Washer only. Is it 1 washer or 2? And the question is the top always this one and it's the bottom? All right. So at least this is a much simpler one. So we go from the axis to the outside, axis to inside. This is a washer. So that means I have a large R. What's my large R? Top. We had y equals x squared, and we had x equals square root of y. Which ones do we use? X squared. All right, and that's top minus what's the bottom? -1. So what is that? X squared plus 1. Little r, top, 0 minus the bottom, -1. What do I have? 1. All right, I can't even tell you how much simpler this is than the way I used to teach it. All right, so we're going to do pi times the integral from, we're looking along the x-axis, this is 1 to 4, of large radius, which is x squared plus 1 what? Squared minus your small radius, squared dx. Okay, I've got time to do one more. Okay. Oh, no. Did I run out? Seriously? No. No. Hey. That's it.
And going to the IC for book today.
Oh, yeah, you decided. When are you going to do this?